Hello and welcome. Today we're going to be looking at complex numbers. This is our last topic on additional topics in math, our last topic on the SAT review. This is going to be the last part of season zero, ground zero, where we learn the skills necessary for SAT math. As always, though, we're going to do our 5 questions. We're going to explain them. We're going to look at their intricacies, help you ace the SAT math portion. If you like the videos or find them informative, please be sure to like and subscribe. And with that, let's get into the study of complex numbers, the last part of the SAT. All right, so we are given 3 over 2 plus I, where I is the square root of -1. We're asked which of them is equivalent to the complex number shown above. All right, we're going to introduce the idea, the conjugate right now. All right, so the conjugate essentially is where if you have a irrational or imaginary number, such as 2 plus I, like we have, the conjugate is going to be where you keep the rational part the same, and then you flip the sign of the other part, right? The sign of the other part. You can do the same thing with irrational numbers, right? If you have 2 plus the square root of 2, you would make that 2 minus the square root of 2. And why do we do this, you might ask? I'm glad you asked, because there is a factorization that we learned a while ago that's going to come into play right now. And that's the x plus y plus x minus y equals x squared minus y squared. X plus y, this one, multiplied by x minus y. Right, of course, we're going to multiply by 2 minus I over 2 minus I, so that's 1. It keeps the value the same. Multiply by x minus y, we get x squared minus y squared. What is the one way we have to rationalize the denominator with this? If we do x squared minus y squared, then the rational part stays rational. The imaginary part becomes -1, right? That we take the I, which is the square root of -1, we square it, becomes -1. We just made it rational. The same thing with irrational numbers. If you have the square root of 2, and you put this in here, then it's going to square that, and now you have 2, you have a rational number. That's why we use this x squared minus y squared. That's why we use the conjugate, this x minus y idea. This idea is super important to remember. The conjugate, the difference of squares is why it works. The difference of squares is also an incredibly important factorization to remember, and this conjugate idea is going to be incredibly useful for you when you're rationalizing denominators in irrational numbers and imaginary numbers, and is going to show up all the time. So you need to know how to apply this. So we've covered what the conjugate is. Now we're going to show how to use it. So we have 3 plus 2 plus 3 over 2 plus I, and we're going to multiply by 2 minus I over 2 minus I. Right, now what? Well, the 2 plus I times 2 minus I in the denominator, well, x is going to be 2, y is going to be I, and we have x squared minus y squared, x squared minus y squared, which is going to be 4 minus -1 equals 5. I was getting a bit ahead of myself. But that's going to equal 5. So the denominator is just going to equal 5 then. The denominator is going to be 5. Numerator 3 times 2 minus I is going to be 6 minus I. And that's our answer, which is answer choice D. Right, so that was the idea of the conjugate. Now we're going to expand upon this idea. We're going to keep using this idea more and more, and we're going to understand how to use it to the max. Let's keep going. All right, so now we have this. We have 5 over 1 plus 3i. We can multiply this on both sides by 1 minus 3i and 1 minus 3i. The denominator becomes 1 squared minus the 3i squared, which is going to be, what is that going to be? That's going to be 1 squared minus the -9. So 1 minus the -9 should equal 10. But we don't have a 10 as an option here. So what happened? Well, if we look at this, right, the conjugate is the way to rationalize these denominators, right? So we have 1 plus 3i and 1 minus 3i. That's how we rationally use. That is a set in stone fact of how we use this concept, right? Now, the fact that I don't have a 10 here just that the problem is incorrect itself. But now this problem is actually incorrect because they should have a denominator of 10 and then numerator would be 5 times the 1 minus 3i. And I'm not sure what they were expecting on this problem, but it's definitely not the correct answer because the correct answer doesn't fit with this question, as you can see, or doesn't. Let's think a bit more critically. Let's see how we can get around this problem of having the 8 in the denominator instead of the 10. And it turns out, well, we have a 5, we have a 10. Right? We can cancel those out. We cancel those out. Right? And we can 1 minus 3i over 2. That's all there is to it. Right? Just because you see the 8 in the denominator, don't start thinking that that denominator has to be 8. Right? You know that the conjugate has to work. The conjugate does work, and it is the only way to do this. Right? If you know the denominator is 6, you should stick to that. Do not put down something over 8 just because it seems like, well, instead of 1 minus -9, if we had like 9 minus 1 or something, right, then that would work. Or if we have like -8, that would be where the negative comes from here. Don't just put that down. You know that the conjugate works. Be confident in that conjugate, and you can manipulate the equation any way you want to, and you will get that the answer is choice B, as we see. Conjugate is an extremely useful tool. Use it, and then you have to apply your already known algebra skills and know that the conjugate always works, and it is always the way to go. Right? Don't try to do something else. Don't put an answer that defies the conjugate. That's just a fool. Let's keep going on this question. Here the conjugate is going to be 1 plus I. So we're going to end up with 1 plus I, the numerator, times the 1 plus I times 1 minus I. That's going to be 1 squared minus I squared, which is going to be 1 squared is going to be 1 minus I squared. So 1 minus -1 or 2. So our answer is going to be 1 plus I over 2. Answer choice D. Let's keep going. Right? Once you get the idea of the conjugate, once you're familiar with this idea, it goes extremely, extremely quickly. Right? So this is a question that looks similar to the previous one. We have the 1 plus I. We have the 1 plus I times the 2 up here. The 1 plus I times the 1 minus I is going to be the 1 squared minus I squared. 1 squared minus -1 is going to be the 2. This time the 2's cancel out, and we're left with 1 plus I. Answer choice B. Let's keep going. Right, these questions go by like a breeze. Pretty easy once you get the fundamental idea of the conjugate. But now we're here. Now we have a question where we have a bit more nuance to it, because this question does not really focus on the idea of the conjugate, right? Now, of course, we're going to first try the conjugate, and there actually is a solution where you can use the conjugate. It's a little more tedious what you would need to solve this problem, but we're going to try the conjugate first. So the conjugate of I plus 4 is I minus 4. I minus 4. And we multiply I minus 4 times I plus 4, and we get the I squared minus 16. Right, we get the y squared minus x squared, the I squared minus 16. And think about what we just did. Right, we multiplied both sides by x minus 4, and we got I squared minus 16 times I minus 4 over I squared minus 16. So this canceled with this, and it's I minus 4. And your answer is just that I minus 4. That's what we do using the conjugate. Now we can think about it in a different way. Right, there are actually 2 more ways to do this. The first of which is similar to our conjugate idea. We just take this I squared, we make it -1. This is -17, and we do the same thing, the same factorization, same cancellation, and we get the I minus 4. This other version is a bit more clever, right? So instead of I, let's consider I, let's get rid of the I, and we'll put like a variable, x. X squared minus 16 over x plus 4. If you remember from difference of squares, then x squared minus 16 is just x plus 4 times x minus 4. X plus 4 times x minus 4. That's going to be over the x plus 4. This cancels out, and you're left with x minus 4. You put the I back in, and you get I minus 4, as we see right there. But you can use any of those three ways. All of them work. All of them are decently quick. Just remember the idea of the conjugate. Remember that I squared equals -1. Remember difference of squares, and you'll be good with complex numbers. That is it for this video. That is it for the SAT review. And make sure you check out the following seasons where we go through actual SAT math practices. We look at the actual question that may explain every single one of them. Until next time, I'll see you later.